All right, good morning, good morning, good morning. While you guys are finishing up this warm-up problem, or just starting this warm-up problem, so I handed back everything that I have. Okay, so that's all back on. You have it all now. Just a reminder that tomorrow there is a formative in the MRC. And Thursday there will be a quiz in class. Okay? So formative on Tuesday, quiz on Thursday. And then that cycle will repeat next week, where there will be a formative on Tuesday and a quiz on Thursday. And then that cycle will repeat the following week, where there will be a formative on Tuesday, but a test then on Thursday of that week. Okay? How long is the test? Haven't written it yet. Kind of waiting to see how many snow days we have in March. So remembering back to Friday, a sub n is equal to a sub 1 plus n minus 1 times d. Okay, that's how we find the rule. We need the first term. We need the common difference between the two consecutive terms to find the rule. Okay? So if I'm going to find the rule, the first one that I'm going to use is I'm going to use this one, and I'm going to say that negative 2 is equal to my first term plus 3 minus 1 times d. I don't know my first term. I don't know my common difference because I don't have two consecutive terms. So simplifying that gets me to a sub 1 plus 2d. Then I'm going to go over here and I'm going to look at this next one, and I'm going to say, well, 43 is going to equal my first term plus now 18 minus 1 times my common difference d. So that's going to be 43 is equal to a sub 1 plus 17d. Okay. I would probably, now we got to run either graphing or substitution or elimination. I'd probably multiply the green equation by negative 1 and add that to the purple equation. Because then my a sub 1's cancel each other out. And that leaves me then with 45 is equal to 15d, so d is 3. The common difference is 3. Plugging that back into my green equation, I would get then negative 2 is equal to the first term plus 6, so I'd get negative 8 here as my first term. Now I have the two pieces of information that I need in order to write the rule for this particular sequence. So that would be a sub n is equal to negative 8 plus n minus 1 times 3. That's my basic one. Standard. Just move the 3 out in front of the set of parentheses. And then we also have our advanced for our higher seeking minds. And those, all three, give us the exact same rule. And if I put in 3 into in for n, I would get out -2, which is good. And if I put in 18, I'd get out 43, which is also good. Okay? So we have sequences. And then today now what we're going to do is we are going to look at finding the sum of series. Okay? Remember that a sequence is just a list of patterned numbers. So numbers that are that have a pattern to get the next one. A series is where we add up all of those terms. Okay? So a sequence is just the list. A series is where we actually add all those numbers to that list. Okay? Last Friday, I gave you this example. Okay? Each brick has a height of 1 foot. How many bricks would it take to build the fact that it's 15 feet? Well, and then we also added the question last week Friday, how many bricks are in that last row? Well, we can find out how many bricks are in the last row. We can use our formula. Knowing the fact that there's 1 brick in the first row that we want to get, if each brick is 1 foot and we want a 15-foot high decoration, then that would be the fact that there are 15 rows to our decoration. And just by looking at it, there's 1 brick here, there's 2 bricks here, there's 3 bricks there, there's 4 bricks there, there's 5 bricks there, there's 6 bricks there. The common difference is 1 brick. Okay. 15 minus 1 is 14. 14 times 1 is 14. 14 plus 1 is 15. So there are 15 bricks in the last row. So we can answer that. Okay? We need to know how many bricks there are in the 15th row because we need to know how many bricks or how many rows that we have to stop. Okay? So that was good. So we can take all of those rows and we can add them up manually. We can say 1 plus 2 plus 3 plus 4 plus 5 plus 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? So we can add all those up manually. 1 plus 2 is 3. Plus 3 is 6. Plus 4 is 10. Plus 5 is 15. Plus 6 is 21. Plus 7 is 28. Plus 8 is 36. Plus 9 is 45. Plus 10 is 55. Plus 11 is 66. Plus 12 is 78, plus 13 is 91, plus 14 is 105, plus 15 is 120. Oh, it's mentally exhausting, right? But we can do it that way. We can always do it that way. We can always write out all the terms in the series and add them up manually. Because that's how we're doing it. We're doing it arithmetically. Okay? So we can always do that. But that might not be the very most realistic way to get to 120 bricks in our sequence. Or in our series, I should say. Okay? Because a little bit later on, we're going to have an example that has 281 terms in it. Okay? So it's not going to be the easiest way to do that all by hand. So there's a formula that we can do, that we can use for it. And this only works for arithmetic series. Okay? So the sum of the first n terms in a series is, I take the total number of terms and I divide it by 2. And I multiply that by the sum of the first and the last terms in the series. give you guys a second to write that down. Very important for today. What this tells you is that you need 3 things to find the sum. The first thing that you need is you need to know how many terms there are. The second thing you need is you need to know what the very first term in the sequence is. And the last thing that you need is the very last term of the sequence. Okay? If you have those 3 things, you can find the sum. If you don't have those 3 things, you need to find the ones that you're missing in order to find the sum. Okay? So, for instance, we have this arithmetic series. Okay? So, I need to know how many terms there are. I need to know what the first term is, and I need to know what the last term is. Okay? Give me one of them. Pat. A1 is what I put on my stake. A sub 1? Yeah. So the first term is 3. I would agree with that. Give me another one. A sub n is 48. I would agree with that. That my last term is 48. How many total number of terms do we have? Don't know, do we? Okay? We don't know. Okay? It's not 5 because of that ... in the middle. Okay? So, let's go with what we know. We know that a sub n is equal to a sub 1 plus n minus 1 times d. Right? Do I know what d is? Do I know what my common difference is? What is it, Sophia? D is 5. Yep, we're adding 5 every time. Right? Okay? All right? So I could say that 48 here is equal to 3 plus n minus 1 times 5. Right? Based on the information that we're given. And can I solve that equation for n? Yeah, I think we can. 48 is equal to 3 plus 5n minus 5. 48 is 5n minus 2. Add 2 to both sides. 50 is 5n. 10 is n. So there are 10 terms in this series. Once I have those 3 pieces of information, now I can go over here and I can say that the sum of the first 10 terms is going to be 10 divided by 2 times 3 plus 48. Ten divided by 2 is 5. 3 plus 48 is 5 times 51 is 255. So if I were to add up all the terms, if I was first to find all the terms of the series, then add them all up, at the end I'd get 255. Okay. Now in the last class, they asked, why is it n divided by 2? And the reason is this. And you don't have to write this down if you don't want to. Okay? So if I started with 3 and then added 8 and then added 13 and then added 18 and then added 23 and then added 28. We'll stop there. We'll stop with the first 6 terms of the sequence. Okay? The reason that it's n divided by 2 is that these two numbers here add up to be 31. These two numbers here add up to be 31. These two numbers here add up to be 31. So if I take the first term and the last term, add them together, then take the second term and the second to last term, add them together, third term, third to last term, and keep working until I get to the middle, that those sums of those pairs are always going to be the same. And so you're taking 2 to get that sum. That's why we have to divide by 2. Total number of terms divided by 2.
Would you allow us to do that as the way like we solve things? Like just to solve how many terms there are? Because then can we just like...
But you can't get n out of that. You know what I mean? Because you wouldn't know, like in the last one, we wouldn't know.
But you could take the first and the last term that they gave us, and then you could add them together to find that, and then you could take the second one, subtract that from what the total should be, and then couldn't you just...
But that would only get you that second to last term. You know what I mean? It still wouldn't get you the total number of terms. Mm-hmm. Later on in life, yeah, we'll do stuff like that where I give you the sum and then ask you to go find like the last term or something like that, working in reverse. Mm-hmm. Okay. All right, sigma notation. We had some sigma notation, remember, from before. Sigma, remember, has a starting value with a variable below it. It has an ending value above it, and it's got a rule after it. Okay? So we take whatever the starting value is, we plug it into our rule that gets us our first term. Then we take the next integer, we plug it into our rule that gets us our second term. Next integer, plug it in, third term, and so on and so forth. And we rinse, lather, and repeat that process until we get to the ending integer. Okay? So writing things out in sigma notation. Okay? So if I'm going to write this out in sigma notation, the very first thing I would do is I'm like, okay, I'm going to start with that's the first term, second term, third term, fourth term, fifth term, sixth term. So I've got 6 total terms here. Okay? So my starting value is going to be 1. That's going to be where when I say start, that's the first number that I'm going to plug into my rule, is 1. My ending number that I'm going to plug into my rule is going to be 6. Now I just have to come up with said rule. My first term is 16. My common difference is I'm subtracting 8 every time. Okay. So that could be a rule. Or that could be a rule. Or that could be a rule. Okay? Basic, standard, advanced in terms of our rules. Putting those into sigma notation now. My variable is going to be n, and it could be anything, but then I would have to change it to fit it to 1 to 6. That's where those two come in. And then I could go 16 plus n minus 1 times negative 8. That would be my basic sigma notation. That would be my standard sigma notation. And that would be my advanced sigma notation. Okay. All three of those work for me. Okay. What I'd like you to do now is I'd like you to find me sigma, or write that series, the second series there, in sigma notation. I'm going to start at the first term, and I'm going to end at infinity because it goes on forever. So that one is going to be infinity. My rule is going to be 3 plus n minus 1. And my d is 7. I'm adding 7 to each and every one. So that's my basic one, my standard one, and my advanced one. So the sigmas would be from n equals 1 to infinity of 3 plus n minus 1 times 7. Three plus 7 times n minus 1, and that. Questions on that? Okay, let's utilize sigma notation. Okay, sigma notation automatically makes it a series. Okay, sigma is not used for a sequence. Sigma is only used for series. So you are finding the sum. Anytime you see the symbol sigma, that means you're finding the sum of whatever it is. Okay? So if I'm finding the sum of whatever it is, I need my first term, I need my last term, and I need my total number of terms. Okay? I need those three things. Now, To find those three things, because you don't have the list in front of you, you actually have to do a little bit of math in preparation for doing this. So to find the first term, you are going to plug the start into the rule. So in this case, I'm going to plug 1 into my rule. So that gives me 3 times 1, 3 times 1 plus 2. 3 times 1 is 3, plus 2 is 5. So my first term is 5. To find the end, you're going to, or to find the last term, you're going to plug the end number into the rule. So that's going to be 3 times 65 plus 2. That's a bad 5. Much better. Okay. 3 times 65 is 195, plus 2 is 197. Oops. And lastly, your total number of terms is going to be the end value minus the start plus 1. So that's going to be 65 minus 1 plus 1. $65 minus 1 is 64, plus 1 is 65. Okay. Now you have the three values that you need to find the sum. So the sum of the first 65 terms is going to be 65 divided by 2 times 5 plus 197. Is that 202? Yeah. Okay. I can divide either one of those numbers by 2. So the sum of the first 65 terms is 6,565. Questions on that? Find me the sum of that sigma series. For my first term, I got 64. For my last term, I got 952. And for the total number of terms, I got 75. Any questions on those numbers? So the sum of the first 75 terms is going to be 75 divided by 2 times 64 plus 952. That's going to be 75 divided by 2 times 1016. I get 38,100. Yes? One more. Last one. First term I get is negative 12. Last term I get is 1,108. Total number of terms I get is 281. (1,108) plus negative 12 is 1,096. 1,096 divided by 2 is 548. 548 times 281 is 153,988. Yes, okay. Again, don't forget that tomorrow there is a formative in the Resource Center. Okay. Thursday there is a quiz. This homework will be due on Wednesday. And if you've learned anything about reading Sigma notation, it starts with homework 12.2b and it ends with fun. Ha ha, he, math jokes.